Hello everyone and welcome to Cloud Launch and Learn Marathon session. And I'm glad to present this session for everyone. We are going to look into Cloud ETL and ELT services in Azure. Little bit about myself. My name is Elhan. You can just call me El. I have been a number of years in Microsoft MCT, and I'm part of different communities around the world, including Microsoft technical community and as well as HL7 Fire community. I'm running the blog as you see on the screen, thecloudmarathoner.com. Feel free to visit that blog and connect with me on social media. Mainly, I am on LinkedIn. You can also check my Twitter and as well as the session and the code that I'm going to demonstrate is going to be, you can find that on my GitHub repository, and this is my GitHub username. All right, that's it. Next, let's briefly look into the company where I'm working. I'm working for TRex, and it's a mid-sized company. It's a very good place to grow your career and do interesting work. So we are mainly specialized in serving our government and federal civilian agencies, with US Census Bureau being the largest customer, where our team did an excellent job in executing US 2020 census with zero downtime. So this was a big success. It was first time done in the history of United States. And this project actually very big, where there's a big mobilization of people who are trying to do the census work for the next decade. All right. And TRex is actually number one provider of cloud services within federal civilian space for the last 4 years. And we have strong partnership with leading cloud solution providers, and we have a mission critical focus on delivering multi-cloud solutions to our customers. And if you are interested in doing the cloud work and doing the engaging and mission critical work, check out open positions on TRex Solutions website, and feel free to reach out to me if you have any questions, and I would be glad to help. Okay, now we are moving to the main portion of our demonstration, which is the presentation itself. And let's look into what we will cover in this presentation. We will start with ADF Concepts, where ADF stands for Azure Data Factory. Then we will look into the pipelines and activities. Then we will switch and look into linked services, which are basically the data source connections or services where you can run compute. Then we have data sets and then we'll look into concepts like pipeline execution, monitoring, and we'll look into triggers, how we can schedule and automate the pipeline execution, and data flows, which are a very important part of the cloud-based ETL solution, namely ADF. We will conclude our session with Azure Data Factory demos and Q&A. Okay, let's move on. So what we will not cover in our section in this presentation is listed on the list. Namely, we will not look into the third-party integration services. We will not have time to look into the CI/CD related concepts that you can actually integrate with the ADF pipelines. We'll also skip ADF supported external activities, and as well as integration runtimes, even though I will touch briefly about integration runtime, and we will not talk about advanced topics as it is beyond the scope of this presentation. Okay, that's it. Now we are moving to the section where we need to learn about what is ADF and why we should know about ADF. All right. So what is ADF and why? That's, I believe, one of the most important questions, because in a real world, every project actually requires data and some type of analytics. there is a need to trigger the batch movement of data or to set up a regular schedule as a requirement for most analytical solutions. With with Azure Data Factory, you can have a service that can be used to fulfill such requirements and perform your ETL and ELT workloads. ETL is extract, transform, and load, while ELT is the modification of that, which is widely used in cloud data transformations. With ADF, which is again Azure Data Factory, you can get a cloud-based data integration service that orchestrates the movement and transmission and transformation of data between different data stores and compute resources. As you may see on this graphic, actually on the left side, we have the different data sources, relational and non-relational, while the data processing and the movement of data happens in the middle layer. And then on the right side, you see that those ready data is actually consumed by data analytics tools, which your customer may have in place in their disposal. So, and what ADF does within given concept is basically it integrates all these data pieces at scale and make sure that you have a visibility monitoring on the process, how your data movements and orchestration happens. Okay, so let's dive into details of ADF concepts. What is inside of this Azure Data Factory? And here we'll first start with pipelines because that's the important piece that you need to have in place. With a data factory might have one or more pipelines, and a pipeline is a logical grouping of activities that performs a unit of work. Together, the activities in a pipeline perform a task. For example, a pipeline can contain a group of activities that ingest data from Azure Blob and then runs a Hive query on an HD Insight to to partition the data. The benefit of this is that the pipeline allows you to manage the activities as a set instead of managing each of them individually. The activities in a pipeline can be chained together to operate sequentially, or they can operate independently in parallel. That said, next concept is activities within pipeline. So activities represent a processing step in a pipeline. For example, you might use a copy activity to copy the data from one data store to another one. Datasets is another concept where this concept is used to represent data structures with the data stores within the data stores. For example, if you have a Azure SQL database as your data source, then data store can store the query results that you are getting from querying the tables within that data store. So basically what datasets do, they simply point to a reference. They simply point to or reference the data you want to use in your activities as inputs or outputs. And then we have linked services, and linked services are much like connection strings, which define the connection information that's needed for data factory to connect to the external resources. Finally, we have mapping of data flows, where we create and manage graphs of data transformation logic that you can use to transform any size data. With ADF, you will execute your logic on a Spark cluster that spins up and spins down when you need it. You wouldn't ever have to manage or maintain those clusters because Microsoft Azure does that for you. And finally, integration runtime. Integration runtime is a compute infrastructure used by ADF to provide data integration capabilities across different network environments. That said, it might be confusing to understand the relationship between these concepts, so next graph should clarify this relationship. where we see pipelines on the right edge, and we see activities in the middle, and we have data sets and linked services. So if you look into this relationship, you can see that we need to have a pipeline which is a logical grouping of activities, and activities can produce or consume data sets, and as well as they can run certain services like linked services that are defined on the graph. In order to simplify this in order to simplify the understanding and get better kind of insights into what it is, I have a short video that I'm going to share on the screen, and this one should help to better understand.
Understanding the components that are used within Azure Data Factory will enable you to easily create cloud-based data integration solutions. One of the first components you will create is a linked service. These are much like connection strings, which define the connection information needed for Data Factory to connect to external resources, such as Azure Data Lake Store or Azure Databricks. With this defined, you can then create datasets, which is a named view of data that simply points or references the data within a linked service. Data typically flows from the datasets within a linked service into activities. Activities enable you to perform an action on the data, such as copying the data or using the data in a compute resource. You can have one activity, but it is typical that you perform multiple activities on the data. These are grouped together in a component known as a pipeline. The pipeline allows you to manage the activities as a set, instead of each one individually. You deploy and schedule the pipeline, instead of the activities independently. You can dynamically update components, such as linked services at runtime, by adding parameters to give you the flexibility of using the same solution in multiple environments. In addition, the integration runtime component provides the compute infrastructure used by Azure Data Factory. It is referenced by the linked service or activity and provides the compute environment as close as possible to the target data store or compute service while meeting security and compliance needs. When authorizing Azure Data Factory solutions, you can make use of control flow components to control the flow of activities within the solution. Not all the components are necessarily required, but by understanding them, you can pick the best ones to build your cloud-based data integration solution.
All right, now we are back after this short demonstration, and we are continuing from where we left. So this short video clip actually gave good understanding about the relationship between these ADF components, where pipeline is a required piece of it, where we may have multiple activities, data sets, and linked services. That said, there's another view of the same concept where we can see that what ADF does, where it's basically a data-driven workflow that consists from multiple pieces, where we have connect and collect piece for ingestion of data. We have transform and enrich, where we prepare the data. Then we have this publish state, where after the raw data has been refined into business-ready consumable form, from the transform and enrich phase, we can actually load the data into data warehousing solutions like Azure Synapse Analytics or Azure SQL Database or Azure Cosmos DB, or whichever analytic engine your business users can point to from their business intelligence tools and consume this data. Important part of this ADF is the monitoring. With Azure Data Factory, there is a built-in support for pipeline monitoring via Azure Monitor, API, PowerShell, and Azure Monitor logs, and health panels on Azure portal. With these tools, we can monitor the scheduled activities and pipelines for success or failure. And that monitoring actually is defined here on the right side of the once the data consumption happens on these analytic tools on the right side. Okay, that said, I want to switch into the demos. And the first demo that we will have is going to be focused on data copy activity. And what we are going to demonstrate here is that a Azure Data Factory pipeline that's created, which has a copy data activity from one data source to another. In our case, it's going to be the Azure Blob Storage, which will have the CSV file that will get moved or copied into Azure SQL database in a form of a uh, understandable tabular data. And this is the screenshot on the screen that you see. So let's have a look into this demo. So what I actually have a readily made. This is the environment where the resources are provisioned. All right, and what I have here is actually uh, as you see, it's a blob storage. I have an Azure. I have here the data lake, as well as two data factory, Azure Data Factory Azure Data Factory instances, and as well as uh, SQL Server that's defined that we are going to use in this demo. So to start with the first one, which is let's have a look here. Okay, so pipelines. Here we have the pipeline. So what I'm showing you now is basically, let me make it a little bigger and zoom probably. So what we see here is a copy data pipeline, which was actually created from these activities here. So it's a copy data activity that you can just pick, drag and drop on the panel here. Let me just show it another one. So once you drag and drop this new panel, you would have to define the name, and you can define the name for this on the right side here. Let me click on it. And here on the, as you may see, you just click on this toggles. Okay. So once you navigate there, you'll be able to give the name for your copy data activity, description, and other details. Okay. So in our case, I'm not going to, I'm already created one, which is here defined. And while we have it here, I'm going to enable actually this other demo, because when you enable you have to enable integration runtime here in order to see this demo, and this process actually takes 5 to 7 minutes. I'm just warming up this instance, and I will talk more about that. But now I switched back to our initial demo of copying data from Azure Blob into the SQL Server, Azure SQL Server database. So in this case, again, we have a copy data activity. When you look at this, you will see that it has one pipeline here on the left side. We have one pipeline here, okay, and then we have two data sets. Let me show you here. So what we have one pipeline, we have two data sets, and if you look into data sets, you would see that it has output SQL data sets and source blob data sets, where the data actually is defined. But in order to see what they actually mean, all right, so let me actually click on this, and now we are looking into the copy data activity. Within this copy data activity, we have source, which has the source data set, which is source blob data sets. And if we want to look what it means, what it has inside, we need to click on this open. And once you click on it, you would see it's actually consuming, it has a linked service called Azure Storage Linked Service. You can click on test connection. It's a CSV type. We are looking at the source blob datasets. We are testing connection now. So it takes some time, but what it should basically testing is here in data storage. As you may see, we have a container, and within the container, we have this ADF tutorial container defined, and it has this emp.txt. What it is, it's basically it's a sample file that has the first name, last names defined on a text. Okay, that's what it is. And that connection that we are trying to test here is actually testing this connection of the connection to the same blob. It's within the container ADF tutorial, and the name of the file is emp text. And if I click on edit here, you would see that same connection information is defined here. This is the name of the storage account. We are using connection string. If you define that sensitive information in Azure Key Vault, you can use that one, which is recommended, or you can use managed instances, managed identities to do this connection if it's available. But once this connected, basically important step here to remember is to make sure that you are using first row as a header. Okay, so that would be basically making sure that when that file emp.txt is actually get read, it will take into account the fact that first row is going to be the header, and any subsequent row is going to be the row of data that needs to be moved. So this is the connection. The schema is automatically defined here with the first name and name, and we don't have any parameters. So this is basically source, the source of this data copy activity. Now let's look into the sink where this data is going to end up. So in our case, it's output SQL dataset. If I click here on open, it will tell us that it's a connection to linked service called Azure SQL Database Linked Service. We can test the connection and look at that. So let's click on test connection here. It succeeded. If I look into details, you would see that it's actually a connection to the Azure SQL database. It's using the to the database name my cloud launch and learn demo, my CLL demo. So let's have a look into that. And here, when I click on preview data, it's going to preview data from the table called dbo.emp. Let's look at that. And we see that it has actually around 10 rows, and it's not empty. It has first name, last name. So let's look into that in more detail using a familiar tool, SQL Server Management Studio, which most of you probably are familiar with. So I'm launching that tool now on my other screen. So once this is launched, what we will do, we'll basically make sure that there is no data in the table DBO EMP. Okay, so let me connect and bring that screen. It's coming up now. It's a bit, and here it is. So I'm connected to that instance in Azure SQL database, and this is the database name. All right, here are the tables. So we should have at least one table, DBO EMP, which is there. Let me open the queries that I have readily open. Okay, let me bring the table. So we have this first query that's gonna run against the EMP database. Okay, against this database, and it should bring us the count of rows, and say there are like 20. So even in order to run our demo, what we are going to do is we are going to truncate all the data that's available there. Okay, so I'm executing this command. It succeeded. And now we are going to run the same query again to make sure that there is no row, no data left on this table called DBO-EMP that we have here, okay? That's what we are doing, and there are no data left. That's good. So I'm going back to this, refresh this connection to the table, dbo.emp, and I'll make sure by clicking on preview data that there is no data. And indeed, we have no data, which is good. So basically what should happen, just to recap, is from that source file that we have in blob, we are going to move that data into the SQL database, okay, that has this table called the EMP. In terms of mapping, we are going to use the built-in mapping. So it's going to basically take that first name and last name columns and map them into the column that we have in DBO database. Okay, and there isn't any specific there's a degree of parallelism and plus the price, right? So we just keep in mind that whenever we are going to use our pipeline and execute that, based on how long does it take to execute the pipeline, we are going just to pay for that duration. And that duration is calculated in DIUs, which stands for data integration units, that measures the and represents the power of single unit in Azure Data Factory. And what we mean by power there, it's a combination of CPU, memory, and network resource allocations called DIU. And this applies to Azure Integration Runtime. Okay, and you can learn more by clicking on this link and reading about that. Okay, so that's it. Let me recap here what we are doing. We have a copy data activity, which has a source from blob storage file. It's going to move that data into Azure SQL database table called EMP. And that's defined here. If you remember, I showed it. And that's it. So let's do that. So what we are going to do here, we'll validate the pipeline to make sure everything is fine by clicking on validate link on top. So it's everything seems fine. Then we'll click on debug. Okay, we'll click on debug and see how it works. All right, as you may see, for it says it's queued. All right. Can click on refresh here and succeeded. So it didn't take too much. It has an ID. Each run will have an ID. It says succeeded. And here in this section, you can actually get valuable information regarding, let me show you, regarding the input, output, and as well as to see what happens. So I'm going to click on this details section, and it says that there were movement of data from Azure Blob Storage into the Azure SQL database. 4 rows have been moved. It took 3 seconds, and this is the queue, and all other information are listed here. So in order to see that this actually happened, I'm going to switch back to my Azure SQL Server Management, not Azure, but SQL Server Management Studio, and I'm going to rerun the query here, execute, and I have 4 rows. If I looked into the details of that rows, let me just put the star here just to simply look, and we see that all that 4 rows have been moved into the Azure SQL database into the table dbo.emp. That's where we are, and you can also see that here on top where we run the query against. Okay, so our data movement pipeline succeeded by moving that data. Okay, so that's the first demo. I hope it was clear what we're trying to do and what was the intent and how we did that. I'll just mention one more thing here, that the data is actually the thing that we are doing is everything is actually saved into the GitHub. And once you set up your pipeline, you are going to be offered to create the connection with your GitHub location where it's going to be where all this data and validation, everything is going to be saved. And it will also have this ARM template. Okay, and you can publish any change that you have so that they can get saved into your GitHub repo. All right. So, and to show you how it looks on GitHub, let me bring the GitHub repository. Okay, GitHub. I'm navigating to the GitHub now, to my repos, and I will share that momentarily. Here's the GitHub repository. Here under the repositories, if you look, you have this ADF sample, okay, and ADF mapping flow. So if you look at ADF sample, this is basically the pipeline where we use the copy data activity. It has main and as well as ADF publish. So I will look here. This is the manual ADF where you have partial ARM template, how it is defined, linked templates, and as well as the definition of the template in ARM JSON language. Here's you see that it's ARM template parameters, and everything is defined here. Basically, you can check it out later on, okay, so that you know that this is the first one. And now I'm going to look into the second demo, and to show that on the slides. The second demo is a bit different. It is going to talk about data transformation using the mapping data flows within ADF. And in this demo, what we are going to use is we are going to do that from the user interface that's provided by ADF to create a pipeline that copies and transforms data from an Azure Data Lake storage source to another ADLS Gen 2 sync using the mapping data flow. And we will use a sample data from a movies file, movies data source that's come out in US between years 1910 and 2000. So basically, it's going to be the collection of movies with ratings. And our purpose would be to find average rating of comedy movies. Again, the configuration of this pattern can be reused in other mapping flows, but this is interesting mapping flow where we are using this tomato meter to define the rating of comedy movies. All right, so let's look into that second demo. I'm going to switch to the second demo where we have actually let me show you in the beginning. If you go there, you will have such a screen, and to see the pipeline, we just click on this authoring. Okay, and if we, as you see here, we have one pipeline called data flow umbrella, and we have two data sets. If you click on these data sets, you will see that first data set is movies DB and another one movies sync, where data transformation is going to be saved. So in order to see that, as you see, we have data flow debug here. So what it is, this is basically a debug mode which permits us for interactive testing of transformation logic against a live Spark cluster. Data flow clusters take 5 to 7 minutes to warm up. So if you are going to present any demo or you want to work on it, make sure that you give yourself enough time for this debug mode to get enabled. You can always turn that on first if you plan to do any data flow development, okay? And I will show you what it means actually. why we need to have that on before we are doing our demo. So this is the basically we have data transformation. Here, when you open the, you would see that here's a data flow, right? This is data flow activity that we are using here. And for any data flow activity, it will be defined here on your panel on the left, as you see here, transform movies. So I'm going to click on that, and the data flow activity, actually, as you see, it has 4 steps here. So first step is to get that data from movies DB. Then we are running a filter on years. Then we are aggregating by comedy genre, and then we are looking into the result, which year we have the highest rating of comedy movies on a given data within the given date within the given years of range between 1910 and 2000. That's the whole idea. So if you click on the first step, you see we have data preview in green. This is important thing because you would be able to see the data in action. So querying and everything will happen while we are developing this data movement, data flow step. So here basically as a source, you see that it's getting it from movies DB, it's a data sets, and you can test the connection here to that data set to make sure it's actually active, so we don't run into any issues while looking into other steps. So while this testing connection is still running, and we can click on open here, this is basically getting the data from simple data file paths that we have on our uh, Azure Data Lake, and this is the connection to that CSV file. So just to show that on our, let me go back to our environment, and here under Azure Data Lake containers, we have this sample data, and this is the movies DB that we have here, okay? So this is the one from where data is coming. So if you right click on that and look into that file, it's pretty big file, but it has movies, titles, genre, year, rating, and Rotten Tomato rating. This is the movies rating system, and the number there actually differs between 0 to 100. Okay, so each movie has their own identifier, title, genre, and everything. So we are going to use this file, and this is the source from where this data is driven. Okay, and again, first row as a header, and this is the schema that we have on that data source. Okay, I'm all right. So basically, this is everything. So we have a source. We have this projection where if you want, you can actually change the format of this data. And then we have finally, we can have a preview of data by clicking on refresh. If you don't have a direct access to see that data source within the ADLS, you can always try to preview the data, but you need to make sure your debug mode is on and this tab that we have here is green. Otherwise, that data would not come up. It will take some time to fetch that data and bring it, but here it is. Yeah, so we got this data. As you see, it has certain rating. There's years. There's a genre where you may have more than one genre, and they are separated by this pipe. We have the title for the movie, the identifier year. So this is the basically source. Second, what we are going to do as a second step in our data transformation is filtering the years. And we have expression here. You can open the expression builder and look at that. And as you may see, it's actually uh, pretty understandable where we are filtering based on the year. And we are making sure that the genre is comedy. All right, that's the where we run our filter. I'm going to, okay, go back there on the filter. And if you go to data preview and click on refresh, it's actually going to run that filter on on that existing data source. And as you may see, you may have different data sources. So now, because that query actually ran up, so we only see the movies between 1910 that has actually comedy. All of them have comedy genre, as you see. So it's much smaller data set than previously. All of them have comedy genre. Okay, now next step is aggregation of these comedies based on year filter. That's what we see here. So it's if you, and this is the and average rating based on year is defined as one of the columns. So in data preview, if I click on refresh, it should basically take that filtered data and aggregate them based on comedy ratings. And here we go. So we see that for each year, we have different comedy rating, and the highest one is on 1964, as far as I see here. And there are different ratings. No, actually 1952 is also good. So we see all this information here. The aggregation again happens on based on the comedy movie ratings on a given year. Okay, and finally this information where we have 83. I believe there's close to 83 rows. So finally, this data is actually synced into the ADLS. Okay, and there's a data preview here. I'm running the data preview operation on last step that we have here. It will take a little bit of time because of aggregation that are happening. And here we go. So we have the pretty much the same statement. And now if I close this and go to the pipeline and we would like to debug this to see, what would be the result, you can always click on the debug here. Okay. So now we are debugging the transformation of data from one store to another data source. And this is as you may see here, transformation is actually queued to happen. And we can click on this input. It will tell us what are the steps. As you may see, it's still running that. This circle is rotating. It will take some couple seconds here before finishing. Can also refresh using this icon here, and plus can always check the status. It should take a couple more seconds here, and we can view the results, input and outputs here, and as well as progress. Once you navigate your mouse here, you would see them. Let me show you. Here we go. Still progress in. And the way how you navigate, basically, if you click on data flow, you can actually look into the pipeline itself. But because this data flow actually defined within this data flow on the left, so if you want to see the actual transformation steps, you need to click on this transform movies, and then you would see all the steps. So let me go back. So this actually the debug succeeded. We have green here, and we have another green succeeded status on the top. So here, if you click on details, okay, let me click on that. It will tell us that at the end there was 83 aggregated comedy ratings, and this is how much time it took to run this. Okay. All right. So that said, we actually did data transformation, and I just want to show you scheduling, which I'm going to do that on a copy data pipeline. Here we have a trigger, as you may see, so you can set a new one, or look into the existing one. In my case, I'm going to click on existing one. I have a trigger here that says run this process every minute. And in order to that, we need to schedule it. I'm going to click on it. And then we need to set the start date and end date, the time zone, and how, based on a minute, an hour, how we want that to be running. As you may see, it's a weeks, months, hours. So I'm going to run that every minute. I'm going to make sure it's actually today's date and the local time, which I am on now, 11:04. Hey, it's a PM now. Okay. And then same thing for the end date, where I will make sure that it can run at least 3-4 times. Okay, so we have correct date. We say okay. It warns me that I should publish that. I'm clicking on save and then publish. Okay, and I should say okay. So as you may see on the right corner, it will say that publishing started. It's deploying the resources now, and publishing completed. So what happened actually here is then it's actually going to generate the ARM template with the change that I produced and show the notification if it is succeeded or not. Okay, so where we are now, we are at 11:03. So in a minute it should start, but we can also, trigger this pipeline manually. So how we can monitor what happened to this pipeline? In order to get that information, we need to navigate to the right side. Okay, let me navigate here and click on monitoring. So I'm going to click on that monitoring here. And here, once we're on a monitoring, you can always filter by debug mode and triggered mode. So in my case, I'm looking at last 24 hours. If I click on debug, as you see, because we run, once we run the debug today, this is the time, this is the duration, and this is the name of the pipeline. And it was manually triggered, as you see here. This is the debug mode, how we run that. Now, if you want to see the details, or you can always click on consumption. It will tell you, what was the consumption here. I'm going to refresh this, and instead of debug, now I'm going to switch into the triggered mode to see what triggers has run here. And once it's clicked, refresh, I see that actually the first triggered run happened on the time that we defined just few seconds ago, maybe a minute or two ago, which is 11:04. And here we see that it's actually succeeded. It runs. So each time it runs, it's going to add some data into the database. So in our case, it's actually, if you remember, I switched back to our. So if I looked at the count here, let's execute. So I have 8 rows because it added 4 more rows from the file. So let's refresh. Okay. So now it says that we have actually we run it 2 times, which means that if I run this, it's 12. It was 8, now it's 12. So it's going to basically add more and more data into the table from the file by moving the data. So if I click on the pipeline again, if you remember what this pipeline is supposed to do, it's basically moving the data from one source to another. Here, each time it's moved the data, it's moving 4 rows from our blob into the Azure SQL table. All right, and this will continue till our schedule ends, meaning for the it will run a couple more times, and you can always go back to the dashboard. Now let me click on monitoring, pipeline runs, yes. And then as you see, it's actually just started executing the next one because it was the next minute. And if you click on refresh, it will tell us did it succeed or not. It will tell us what's the name of the trigger, when it started running, how much time it consumed. All right. So that's pretty much it. We showed two demos. First, we start with demo one of data copy activity, where we moved data from Azure Blob Storage into the Azure SQL database and tables that we have there. Then we looked into data transformation, where we transform movies DB by filtering on years, then aggregating by specific genre. In our case, it was comedy, and then sync. And finally, I want to recap our demo today with what we have covered. We looked into ADF concepts, we looked into pipelines and activities, we looked into linked services and datasets. Then we looked into pipeline execution, where we have the debug mode or schedule mode. Then we looked into monitoring activity, and we looked into what happened to our pipeline during the execution. We looked into triggers, how to set one, how to schedule one, and we looked into data flows. All right, that's it. Now we are in a section of Q&A. So if you have any questions, please drop in the chat and I will be happy to answer them. If you get some other questions later on, keep in mind that you can get connected with me on LinkedIn, and I will be glad to help you in your challenge. And here's my Twitter account, which you can connect with me, and you can check the code on my GitHub repository. All right, that's it. Again, this was a simple introduction into the EDF and ETL, ELT service in Azure using the Azure Data Factory. And I hope you liked the sessions. Have a great rest of your day. Bye for now.